What's up, guys? It is part 2 of day 72. I've heard what you guys have to say, and apparently, and you guys are right. I mean, I should learn assembly before I attempt something like this. So that's what I'm gonna do. We're gonna learn assembly. I think I want to learn the x86 registry, but if we're doing OS development, oh no, that's right. But if we look in our source directory, I think this is they're talking about 8-bit register. Was the register up here at 16-bit? But let's start this. So it's still going to be our OS development series, but I'm going to add a little bit of a twist to it, where we're just going to learn assembly first before we learn anything else. So let's get started. So assembly language course. Not in Hindi, because I do not know Hindi. See, I watched a little bit, but and I can only do an hour tonight because I have work in the morning. Okay, so let's exit out of this, make an assembly directory. Learn. I guess we could keep learn. Give him a.asm. Global start. So that's going to be our declaring this will be our starting point. A value R into 7. It's one example of a special purpose registers that we have. Okay. Something the list of numbers. Okay. I get reading it out in the memory context, but I just want to learn. Here we go. My first program. So make that clear. Okay, I think I know this part. I just want to get into move. We need to give it a destination. Okay. Constant value into this. What the fuck is he talking about? Okay. Move 30 into register 0. So if we do this, R7 into 1, so R7 or R would equal 1. What does SWI mean? So straightforward, so simple. Disassembly tab. Let's look up another tutorial. It's just so confusing. I want like a simple tutorial. Here we go. Here we go. This is what I want with NASM. Beautiful. What's going on? Well, so our first NASM program. You guys gotta peep the llama. Okay, bro. Let's get started. Section.data, section text. I think I know what these do. These are where we define our variables. And then this is our starting point right here. Start label. From here we could actually start writing all of the code for our program. Yeah. Today is to move a static value, it's like an integer value, into a register. So you want to move the register. An interrupt. It's EBX to 1, and then interrupt 0x10. I believe that's it. or yeah, 80 0 or 80H. That what we want to do when the interrupt 80 is called. In this case, what one indicates is run the exit system call. So would we just do syscall? What system call we want to do in this case is set to 1 and 1. Will we exit the program? Oh. Okay. Okay, no, it's making sense. Okay, so say there's like a standard output variable. We just move that variable into that standard output register, and it should output the data, right? Hold up. X60. So EBX 8. Okay. So say I want and this would be 4, 5, so it'd be 10. So it'd be 10. So we'd move 8 into EBX. We'd push EBX. And then we push our message. Right? Oh, and then we call printf. If you want to print out a number, oh, it's all making sense. So the registers are the values that you want to do. So like, say, EDX is the standard output, right? You'd move your message into that standard output, and then it puts it into the output. It's kind of cool, but you just have to memorize. You know, it's kind of like functions. Like say like in Python you do like dot sort, but in here you wouldn't. Now I want to run this. Nasm.f elf parser. And what? 5? Wait, what? Okay. So that's that. And then LD 8.0 dash OE. Undefined reference to ASM and GCC dash M32 dash OE A dot O. Okay, so wait. You would then to 8 and then return and not have the interrupt. Kind of like this. Push D word. Right call number. We run an interrupt. Zero x80. We don't have to extern printf. Do we push EBX? How to compile x86 assembly. That's not what I want. LD-M elf x86 64 3.0 dash OE. I'm so confused. Let's just keep watching the tutorial, see how he compiles it. Okay, how I compiled it. Okay. I386. Oh. No. Oh my gosh. Segfault out the wahoo. Maybe I wouldn't push EBX to the thing. I just... Why is it segfaulting? Okay. Is this call right? For to write to the standard output. So move that into that register. What does that register mean? A pointer. Move EDX into our length, which are our length would be our equation. Right? Message. Put an interrupt. What does the AL register do? So AL1 to exit the program. Set EBX to 0 because we don't want it to be writing anymore. And then we interrupt again. It's making more and more sense. Wow. So see, if we don't set this to that, would the program ever exit. Oh. So whenever we want to exit a program, see, that's cool. Now we can write whatever we want. Whatever we want. Boom. Wow. Okay, it's making sense. So EAX is our write function. So we set it to write. We set EBX to 1, which is the standard output. We move, I guess ECX is a pointer variable. We move message into it. We move our length into that, and then we do a syscall or an interrupt. And then here we exit the program. Set our standard output to 0. Wow. Okay. See, that's so cool. I like that. Can we write an integer? Say like 43. Okay, that's right integer. X86. So it's weird that they have FMT here because that's the same FMT in Go. Right? So we move. Wait, you add these two. Wait. So instead, this would be our text. Okay. So then now, what we do is we do num1 defined by, we make sure it's a decimal to 10 0. Okay. Sigfall after the print. So instead of this, what if we just put the num and then get rid of this register or instruction. And length equals f number length. That's not what I wanted. That's not what I wanted. That's not what I wanted. DB10. God, I gotta write. Oh my gosh. Get out of my system. Oh. You know, I can make this bigger too if you guys want to see. So this is our exit function. If we didn't have this, it would sig fault. But I don't know why AL has to be set to 1. Write std out what to write the length, then exit. But so before this, oh, see, this is cool. String defined by 100. So this is a buffer. This is technically a buffer. Then we move EAX to the 3. Move EBX to the 0. Whatever comes in, move EDX 100, and interrupt 0, 80. So then I want to print out str, the length will be 100. Oh my god, it's cooked. See, it has hello world. It's got all these null characters. Print 100 bytes starting from string. So I put EAX into the fourth, which is right, and I put EBX into 1. So I will write to the standard output. Then ECX to string. That's exactly what I did. EAX1. I don't understand. 4. I don't get it. So I allocated 100 bytes, right? Oh, wait. Oh. So the input works. Res D. Okay, I guess. So you just gotta learn what registers, do. So see, I have the EAX register, right? 3 is the standard or input. See, 4 right here is output. Or yeah, or not output, it's the write function. This is the read, this is the write. And then EBX here is 1, because that's the standard output. We move into ECX string. Or no, ECX would already be string. So we wouldn't use this function. BSS. So then move, store the number of inputted bytes. So move, but that doesn't make sense. That's not what I'm looking for. If true, so what? Clear EAX. So then would you do like X? EAX. Jeez. I'm sorry, bro. See, it's gibberish. equal str. Alright, so then we just we move ECX into that, and then we define the byte with D. Ooh. Assume that string is null. Okay, wait. Wait, could we do like print move EAX 4 move EBX to 1 move ECX let's just do message move EDX into length, and then we'll interrupt and then we'll delete all this, and then jump print. I think that's how it works. That's right. I need to define what it means. Oh, see, that's so cool. But I don't know why it's not exiting. Is it because of this? Conditionals. Compare. Unconditional jump. So I want to see a little bit of it. So compare. I want to see his code. Okay, so basis of today, we learned input, output, input, output, where can we move? we move ECX is the, I guess, the register output. You know, the syntax isn't that bad. It's just a little bit confusing. JZ X86. Okay. When AL is 2, I could use J. Okay. Okay. So compare. Oh. Okay. So it kind of makes sense. If instead of you putting if, it'd be no, because this would be at the end of our program, right here. So then jolt is less than if R1 is less than R2. Move 4 into EDX and then write, or do we write it to a variable? Define DW? Oh, DW. And how do we write it to the standard output? Would this somehow work? Oops. Why did I say no? Okay. So that didn't work for some reason. Choice. Stars. Um. Okay, so it's it's kind of like that. So that be the reason why? Okay. So increment total. So call kernel, exit kernel. Wait, we don't even need this or this. We just exit like this. Put that. Some of that. So that's cool. It incremented. If it incremented by 1, can we just put the total? See, now that doesn't work. Because EBX would have to be put as 1. Exactly. Let's get rid of all this. We don't need this. Actually, we do need it, but let's just increment it out or comment it out. So we just jump to print. Oh shit. Oh my gosh. Okay. I guess it already does a syscall, so just make a couple notes here so I can look back. std out, right, set eax to right, and then this would be function call function, and then here and here exit program. Where's this at? Okay, I'm gonna have to jump the loop. I don't get it. Oh wait, do we jump? Do we do this? $13. Segfault. Let's go. What time is it? Okay, guys, I think that's it for today. I will see you guys tomorrow. Bye, guys.